Hi guys, Trevor Sullivan here. I am a software trainer here at CBT Nuggets, and I wanted to give you a little bit of insight today into an exam that I recently took in the software industry, and that is the Certified Kubernetes Administrator exam, or CKA for short. Now, this exam is put on by the Cloud Native Computing Foundation, or CNCF, as well as the Linux Foundation. I'm not quite sure exactly what the relationship is there. I think the Linux Foundation is kind of a superset that has adopted the CNCF, but I could be completely wrong about that. In any case, the CNCF, the Cloud Native Computing Foundation, has a repository over on GitHub called Curriculum. And this contains a few PDF documents that kind of describe some of the different certifications that they offer. One of them is the Certified Kubernetes Application Developer. You've also got the CKS, the Certified Kubernetes Security Specialist. And then we've also got the CKA, or Certified Kubernetes Administrator. And if you take a look at the document versions here, you'll actually see that they kind of closely correlate to the versions of Kubernetes that are currently available. So 1.23 is the current version of Kubernetes. And it looks like the CKA has been updated a little bit less recently, about 5 months ago, whereas the CKAD and the CKS have been updated more recently. So it's just kind of interesting how they follow that same versioning for Kubernetes as well as the exams. I think that's kind of brilliant. Makes sense that they would have version numbers for the exams that correlate directly to the open source tool itself. So if we drill into the CKA guide here, this is kind of the rubric, I think you would call it, for the exam, and it kind of covers the different topics within Kubernetes that you are going to be experiencing as you take the exam. Or I should correctly say, you may be experiencing as you take this exam, because there is no firm knowledge that you're going to actually be questioned on all of these topics necessarily. In fact, the exam is approximately 2 hours in length, and so there's no way that you could possibly cover all of these things in just 2 hours, especially if you're testing and having to be extremely accurate about the different answers that you are providing. Now, I should inform you before I go any further here that I have not yet gotten my exam results. I took it with the knowledge that I may not pass the exam, and I'm just kind of okay with that. You know, if I don't pass the CKA exam, I'm fine with that. Of course, other people may be in a position where you need the CKA for a particular job role, or if you're trying to improve your career and your marketability in the software industry, then it definitely would help to have the CKA or CKAD or even CKS certifications under your belt, depending on what you're doing. However, I have been building out a lot of Kubernetes content that is focused on the CKA, and part of my reasoning for taking this exam was actually to kind of just educate myself on any topics that I may be missing when building out my training for the CKA exam. And it did actually open up my eyes to some topics that I needed to go a little bit deeper on as I kind of wrap up this training course that I'm building for CBT Nuggets. So the first major section here, it says 25% is going to be allocated to cluster architecture, installation, and configuration. And I'm actually going to go back and just download this file. Well, let me see if I can actually just open up in a different utility here, just so I can open it up directly. There we go. And I think we'll get better text rendering that way instead of getting that kind of pixelated text that we were seeing in the browser there. And so 25% is cluster architecture, installation, and configuration. This is things like role-based access control. You can create cluster-level roles. You can create namespace roles as well. And then you can bind users, groups, and service accounts to those roles, and you can delegate access to different resources. Now, what's really interesting about RBAC in Kubernetes as well is that you can control access to certain API resources. So if you want somebody to have access to control deployment resources, but not replica sets, then you have that option. You can restrict which individual types of resources they can manage. Plus, you can also specify which operations they can perform against different resources. So if you would like somebody to be able to perhaps list deployments or maybe list replica sets for troubleshooting, but you don't want them to be able to delete replica sets, then you can provide that limited access based on the verb or operation that you'd like those users to perform. So it's really good to be skilled up on RBAC because that could be a very important feature on the exam that you may be tested on. Another topic here is using kubeadm. So this is the kind of official utility, so to speak, that you would use to create a new cluster and upgrade your cluster and just manage it at a high level. So kubeadm is how you would initialize a new master node in Kubernetes, and you can also join worker nodes to a kubeadm provisioned cluster as well. So kubeadm is a good utility to know. You're also going to be tested on, potentially tested on the ability to upgrade a Kubernetes cluster using kubeadm. So if you have been playing around with Kubernetes for a while, you may not have started with kubeadm. You might have launched a different distribution of Kubernetes like K3s or Minikube or maybe Kind Kubernetes and Docker, or maybe you're using one of the cloud-hosted versions like Amazon Elastic Kubernetes Service or Google Kubernetes Engine or Azure Kubernetes Service, AKS. If you're using one of those cloud-based services and you don't know about kubeadm, then you're definitely going to want to get familiar with the kubeadm utility to initialize a cluster, to be able to deploy a highly available cluster as well with multiple nodes in that cluster and joining additional master or worker nodes to your kubeadm provisioned cluster. And you also want to kind of just understand the underlying infrastructure too. It's like how much, CPU and memory or disk should I allocate to my worker nodes or my master nodes and things like that in order to have a well-functioning cluster. Also, etcd is the default state store for your Kubernetes master nodes. It's basically just a key value store that is open source. So you'll want to understand what etcd is, what kind of data is stored in etcd by the Kubernetes master nodes, as well as how to perform database backups and restores for etcd so that you can recover a Kubernetes cluster in the event of some kind of catastrophic failure where you just lose all your storage. Now, etcd does actually support a couple of different architectures. You can actually run an etcd instance on every single master node inside of your cluster, or you can actually install etcd as a highly available service outside of your Kubernetes cluster and then configure your Kubernetes master nodes to actually point at that etcd highly available cluster that you've created separately to use it as its backing store. Now, which is the best architecture? That kind of depends on your particular use case, but you do want to be familiar with etcd and understand how Kubernetes is using it and how to do operations like backups and restores. Workloads and scheduling. So this is where you're talking about actually running pods and containers inside of pods and things like that. And so this is going to cover things like pods and replica sets and deployment controllers and service controllers that are used for load balancing across different pods. So deployment controllers are really important because they allow you to do things like roll out new versions of applications in a somewhat seamless manner, allow you to do things like blue-green deployments in conjunction with service controllers. And so deployments also allow you to scale your application components too. So you can just go to a deployment controller and say, hey, I want 10 replicas of this particular application pod, and it will handle scaling up that application. And then if you tell it that you only want 2 later on at a period of lower demand, then you can simply reconfigure that deployment controller and it will handle doing that scaling up and down for you across all of your worker nodes within the cluster. Well, technically it's the scheduler component on the master nodes that's doing that, but the deployment controller is kind of your end user or administrative interface to manage that resource. You also have config maps and secrets. So config maps are just think of like environment variables. It's like some kind of variable that you need to extract out of your application and share with a whole bunch of different application components. Maybe you've got a database server that's shared with a bunch of different applications, and rather than having to store that as an environment variable on every single pod configuration, you can instead create a config map as a separate independent resource that just stores a bunch of variables as a map or key value pairs, sometimes known as a dictionary or hash table. It's basically that, but it's configured as a Kubernetes resource called a config map. And very similarly, you have secrets. And secrets are very similar to config maps. The only difference is that they are declared as secrets and can be stored as a separate resource that you can then secure as an independent resource from the config map. So if there's certain users that you don't want to have access to secrets, you can use that role-based access control feature that we talked about right up here under cluster administration to delegate that access. We already kind of talked about scaling applications, but again, you've got things like replica sets, deployment controllers, and replication controllers that come into play here. You also have the primitives for self-healing application deployments. So that's really kind of your deployment controller type of thing, where when you create a deployment controller, you tell it how many pods you want of a particular type, and it will handle kind of building that across a cluster. And if any of your worker nodes were to go offline and you were to lose some of those pods, the deployment controller is kind of robust and self-healing in the sense that it will detect that pods that belong to a replica set that belongs to a deployment controller are missing, and so it can kind of self-heal and get that back up and running. Also, you've got resource limits, so you can configure your pods to have soft requests on different resources like CPU and memory. You can say, I need you to have like 100 millishares of CPU, or 50 megabytes of memory, or you can set a hard limit so that if a pod exceeds that, Kubernetes will just kill off that pod and restart it, which is really useful if you have some old legacy buggy applications that you've repackaged into a container, but you haven't really gone through and found memory leaks in the code and fixed those. You can set hard limits on those pods and it will automatically restart those for you. Also, manifests and templating tools. So this is, of course, your YAML manifests that you're accustomed to in Kubernetes to deploy different types of resources, whether it's config maps or deployments or pods or service controllers, things like that. So you want to really understand how manifests are created, things like API resources and API versions as well, along with your, what are they called? Special interest groups. They've got the networking, API groups is what they call them actually. So you've got your networking API group, your storage API group, your RBAC API or authorization API group, I think it's called, and understanding what those API groups are and which resources each of those API groups declares is really essential to being able to build manifest files from scratch and understanding really what makes them tick and the relationship between different resources within a Kubernetes cluster. You also have templating tools. So one of the most popular templating tools out there is Kustomize, which used to be a separate open source project, but now it's actually built directly into kubectl. So you can actually create templates of manifests, and you can apply a bunch of variables to a template and actually generate a manifest by inserting variables into a manifest template. And then that can allow you to kind of make your templates a little bit more reusable, where maybe you've got a dev environment that has a different set of variables than a production environment. You can inject those into templates differently using Kustomize and basically do that before you actually send the data off to the cluster, whereas with something like a config map, you'd actually do that after you provision the cluster. Also, you've got services and networking here, so understanding like connectivity between pods is going to be really important. You've also got things like service controllers, which allow you to expose pods through a load balancing resource called a service. That gives you the option to do an internal cluster IP, node ports, load balancers. You really want to understand those, as well as the selectors on services, because the selector is how a service is going to determine which endpoints or pods it's going to send traffic to and load balance across. Also, the things like ingress controllers, if you're needing to do kind of layer 7 routing with URLs, then the ingress controller and ingress resources are going to allow you to control and route that traffic to different services within your Kubernetes cluster. Core DNS, that's kind of the default DNS server that you've got in your Kubernetes cluster. So knowing how core DNS works is going to be really essential from a networking perspective and service discovery perspective, so that your application can find your database server, or different applications can kind of talk to each other. If there's different APIs that are interdependent on each other, then that's going to be how they find each other through DNS. Also, container network interfaces are really important. There's lots of different CNIs out there. There's cloud provider CNIs. There's open source CNIs from like Calico. You've also got things like the Flannel CNI. You've also got like the AWS VPC, for example. They have their own CNI that allows pods to get IP addresses on a virtual private cloud or software-defined network, essentially. So understanding CNIs is going to be really important. Then you've got storage and troubleshooting. Those are really the last two sections, I think. Yep. So we've got storage. This is where you're going to do things like take a look at storage classes. This is really important when you get into cloud storage, because you can create different storage classes. Like in AWS, you have like GP2 and GP3 SSD storage. You've got cold hard drive storage, you've got throughput optimized hard drive storage, you've got throughput optimized SSD storage as well, IO1 and I think IO2 as well storage classes. So you can declare these different types of storage classes in your cluster and then allow your applications to actually request storage through persistent volumes and persistent volume claims on those different storage classes. So that's going to be really important. Understanding when you create persistent volumes, what volume modes are, access modes, and reclamation policies. Do you want them to be cleaned up after they're released back to the cluster? Do you want to retain them? Things like that. And then you've also got your persistent volume claims that allow you to apply a claim against a persistent volume that's been declared in a cluster, or dynamically provision persistent volumes as well if you would prefer to automate some of that persistent volume management. And then you also want to be able to know how to take a pod manifest and actually tie that into a persistent volume and then mount that storage not just to the pod, but then into the individual containers that belong to that pod as well. So knowing how to kind of map all of those storage resources together is going to be pretty important. And then on the last section here, this is around troubleshooting. This is pretty heavily weighted at about 30%, they're saying. And so this is where you're going to want to know how to find logs for different components like the kubelet, the worker nodes in your environment, pod logging, things like that. You're also going to want to know how to monitor applications. So think about things like sidecar containers. That's a really important concept, to gather logs from an application and then send those logs off somewhere else. Just conceptually, that's going to be a really important concept. Also things like metric server as well, knowing how metrics or custom and external metrics are going to be used within a cluster, especially when it comes to things like auto scaling. If you're doing automated horizontal pod scaling, or you're doing cluster level auto scaling within a cloud vendor to actually increase the number of worker nodes that you have, it's going to be really important to know how to use those metrics in order to drive that. And there's actually a really cool open source project I came across. I can't remember the exact name of it. I think it was, let me look at my tabs. It's called Keda, K-E-D-A. Keda.sh is an interesting open source project that actually helps you implement these metrics and implement kind of automated events and hooks to hook into those events and actually scale up your applications when it's required. Also, the container standard in and out, or standard out and standard error logs, those are going to be really important just to understand how to log from your application pods themselves. Up here, this is actually more just about cluster logging and node logging for like your master nodes and your worker nodes, and understanding if they're healthy and things like that, making sure that your kubelets are up and running so that they're communicating with the master nodes, and just ensuring the overall health of the cluster. Application failure. So this is basically taking a look at pods. It's like, are there networking issues? Are there storage issues? Some kind of maybe a resource issue with you running out of memory that's causing applications to fail to scale up or even be deployed in the first place. Cluster component failure. This is where we're talking about, again, cluster level health things like, is the kubelet up and running? Do I have enough free storage? Do I have enough free memory? Is my CPU being maxed out? Things like that. And then from a networking perspective, just making sure that you understand how traffic is being routed internally to your Kubernetes cluster, as well as from the cluster out to the internet as well, depending on where your container images are stored. If you're using a private internal registry to the cluster, or maybe a managed cloud registry, or maybe you're just using like a totally external registry like Docker Hub you could use, for example, or Quay.io from Red Hat, or a variety of other container image registries out there. So you have different choices for that, and you need to make sure that your cluster is able to communicate with those registries. You need to make sure that your pods are able to communicate with each other. You need to make sure that your services are able to receive traffic from outside the cluster, either through node ports and load balancers. And so understanding core networking and routing, and also understanding just the internal routing is going to be really important here as well. And the last thing I would also mention as well, they don't really call it out in too much detail here under the networking section, but one of the important features in Kubernetes is actually called network policy, and that's where you can actually restrict the communication between pods in a cluster. So that can help to reduce your attack surface on your Kubernetes cluster. If some team develops an insecure component that is hacked by some user on the internet that's maybe running automated scripts to try to hack into your application and use exploits to gain access to your cluster, you can use network policy. There's a couple of different open source ones out there. There's like WeaveNet from Weaveworks, and there's also Project Calico from Tigera. There's also other plugins that you can use gurus out there as well, but using network policy to control and secure your network traffic is a really important concept and something that I would highly encourage you to study up on as well, because that is only going to help strengthen and firm up your knowledge of how Kubernetes networking works and how pods communicate with each other within the cluster and things like that. So I would definitely kind of add on network policy, even though they don't explicitly mention it here under this services and networking section. In any case, I hope that this has been an informative video for you and that you've learned something new from it perhaps, or at least kind of gained a deeper understanding in terms of just the words on the page in terms of the CKA exam. And I would really encourage you to head over to CBT Nuggets. We do have some Kubernetes content that's currently available, and we have a lot more coming up that will be released sometime here in the near future around the Certified Kubernetes Administrator exam specifically. And then we'll hope to build beyond that with more CNCF related content as well. Thanks for watching, and head over to cbtnuggets.com. We have a free tier. You can actually just go to CBT free here, and we've got free IT training, so you can actually sign up for a free account. And if you're not currently a subscriber to CBT Nuggets, you can get acquainted with the content that we have over there. And this is just a really good way to kind of whet your appetite and see what we've got. And then if you're interested in more, you can certainly sign up for a subscription. But if you'd like to support me here on my YouTube channel, then the best way that you can do to support me through that is to go to my employer, CBT Nuggets, and subscribe to our training service. We've got lots of training beyond just Kubernetes. We've got AWS-centric content. We've got Azure-centric content. We've got GitHub training content as well, which is really important for application developers and DevOps around Kubernetes and other cloud vendors as well. And we've also got some content around MySQL as well. So if you're looking to learn about databases and you're really interested in deep diving into MySQL, I've actually got a great course on MySQL specifically as well that's part of our paid subscription. So again, if you'd like to support my work, then please check out CBT Nuggets. Thanks, and we'll see you in the next video. Take care.